Our industry is a global one. Today, this stands for many risks, but we have also many chances. My name is Karl Hoffmann. I'm leading the global metal recycling division of STEINERT, and I'm more than 15 years in the metal recycling business. In these times of uncertainties and risks caused by climate change and geopolitical reshapings, which touches our business models, the question is, what can we do? It is clear, also in our business, flexibility and independency is the key for the future. And that is exactly where we at STEINERT come in. With our adjustable and AI-based sorting systems and our processes, we are creating added value for our customers and for the environment. Our X-ray fluorescence system creates clean copper, zinc and brass, and with our laser-based sorting system, we even produce pure aluminium alloys, ready to use for new car bodies at new parts of the construction industry. And all this is made from used products at the end of their life cycle. Creating closed loop is a need for our future generation. It's a need for the environment and for all of us around the globe. Luckily, technology is there and it's economically feasible. Let's work on this together.
Meeting scrap qualities in order to reduce carbon footprint and how this can be achieved by STEINERT solutions, this is our topic for today. Welcome to this STEINERT Metal Recycling Keynote. And a personality who knows metal recycling in detail is Dr. Simon Heinrichs. Good to have you, Stefan.
Yeah, hello, and thank you for having me.
And I like to introduce our expert to you a bit more in detail. Stefan is Head of Product and Solution Sales Management and already working more than 10 years with STEINERT. He is responsible for the entire product portfolio with regards to metal recycling. And his job is to align STEINERT's solutions products with the customer's needs. So Stefan, you are familiar with the customers and the daily challenges they are facing.
Yes, exactly. Normally our customers know exactly what they are aiming for. But sometimes they do not know exactly how to get there.
And that is the point where you and your team are stepping in. Am I right assuming that this is the case every time it is getting more complex and technically more sophisticated?
Yeah, correct. So the standard technologies like magnet separation and eddy current separation, that is something that is well known by our customers. But when it comes to technologies with shorter development circles like sensor-based sorting, then the state-of-the-art is not so well known to everyone. And that is where my team and I can step in and support our people and also the customers to give tailor-made solutions according to the requirements.
So obviously that has to do a lot with communication, listening, and then offering the tailored solutions as you just mentioned. And after this introduction, we are now entering our first topic, and that is called ZORBA. Stefan, why is it interesting to generate and further treat this material stream?
First of all, ZORBA is a term that is a trade name for scrap quality according to ISRI specifications, and it describes a non-ferrous metal concentrate. And this is already holding the most valuable materials in a waste stream. And this is something that is typically generated by eddy current separation. And it also can be segregated further into different commodities. So to just give an example, the non-ferrous metal concentrate, ZORBA, can be traded for, let's say, 1,500 euros a ton. But it also contains copper, which is worth sometimes more than 7,000 euros a ton. And that is then where value can be created just by sorting.
And what can STEINERT do about it? What solutions are offered?
Well, STEINERT as a machine manufacturer supplies a wide range of sorting equipment for solid materials. And there we also have a wide range of magnetic separators, but also eddy current separators up to sensor-based sorting systems.
And at this stage, what are key technologies to generate added value with scrap metal? Please share with us.
We need a step-by-step approach within mechanical processing. And here, actually, every step already creates a valuable fraction, so to say. So the non-ferrous metal concentrates are generated by the eddy current separator. And here, STEINERT has, with more than 40 years of experience, delivering more than 5,000 units globally, we have set a real benchmark here. And these eddy current separators are typically followed by X-ray transmission sorters to do a dry density separation step. Here we typically separate free heavy metals, but also heavy metal compounds from the aluminium, so from the light fraction. And then, of course, we also can go deeper into sorting by segregating the aluminium into cast and wrought, for example, and even into different alloys.
So at this point we are actually or already at aluminium recycling. You briefly mentioned, but we will discuss that later on in the next topic block. So let's stay for a moment with the sorting of heavy metals that remain after density sorting with X-ray transmission that you kind of already mentioned. Is it a colorful pile when I think about it, with all kinds of different metals? And a concrete question, how do you sort it?
Well, a colorful bunch in the truest sense of the word, because the heavy non-ferrous metal fraction can also be called the colored metals fraction, because it holds copper, zinc, brass, and so on. And here we also can use color as a stable characteristic to differentiate different commodities. And here we can do, just using color sorting, a red copper fraction, a yellow brass fraction, and a gray mixed metal fraction then.
And which machine is used here?
For color sorting, we use our KSS CLI, which is a combined sorting system using a conveyor belt where the material is accelerated through the detection area. And here we combine more than one sensor. So we use typically a color camera, we use 3D recognition, and also optionally an induction sensor. And when the material has passed the detection area, the machine calculates the classification, and after that the target material can be ejected using compressed air blasts to eject the material out of the trajectory at the end of the belt, which happens very precisely, and for materials above 10 millimeter in particle size.
And what about smaller grain sizes?
Yeah, there we have something new. Our M-Sort AK is able to sort particle sizes down to 1 millimeter by color. But different to the STEINERT KSS, we have a chute system here that allows us to move the particles stably through the detection area, where we have a very high resolution camera applied, and also a very high resolution WAV bar. So with the M-Sort AK, we are able to sort small particles with high precision.
And is color sorting, can you say that, suitable for all heavy or non-ferrous metals?
Yeah, so naturally there are certain limits with color sorting. But we see a high accuracy for these type of materials when the particles or the surfaces are visible, so that we can include on the base metal. But when we have the task, for example, to separate then the gray metals like tin, lead or zinc from each other, then color sorting is not really helpful because everything is gray. Or the same applies when the surfaces are getting dirty. For what reason ever, then the surface is not visible, and then also the colors are not detectable. So something else applies if we have coatings. For example, sometimes for the heavy metals, they are coated with nickel or chrome plating, and then simply the base metal is then covered, and then color sorting is not really helpful.
All right, so we understand color sorting has natural limits, but how can you deal with the materials you just mentioned?
Luckily, we have a solution here when the requirements are getting more complex. And that is our X-ray fluorescence technology, which enables us to detect the elemental composition of the materials we detect. Here we use the technology to detect and emphasize on the composition, and then we can classify accordingly into the different material classes.
And can you name some typical sorting tasks here?
Typical commodities to sort are, for example, zinc or copper or brass, which is very common to segregate from a heavy non-ferrous metal concentrate. But beside that, this technology allows us also to differentiate stainless steel qualities like 304 and 316, for example, where we just have the difference of slightly higher molybdenum value. Or we have to segregate different copper alloys just by the composition and the alloying components. Sometimes we also have, depending on the input material, we also can find circuit boards in this mixture. And they hold a lot of precious metals like gold, and this is also sortable using XRF technology.
Do I have to imagine this fluorescence technology also in a chute system?
Well, here we have both. So we offer this technology also in a chute system, but also in a conveyor-based sorting system. For coarse materials, we use our KSS XF L, which is our conveyor belt-based system. And for fines materials, we use our chute, which is then the chute system using XRF technology. Both machines can be equipped with several sorting programs to meet the requirements of the different sorting tasks, so that we can flexibly adjust the system to the needs then.
Stefan, thank you so much for your detailed explanation of the various technologies so far. STEINERT has obviously quite a few solutions for sorting ZORBA in its portfolio. And now we show you these technologies in action.
In our Test and Development Center in Pulheim, close to Cologne, we are happy to welcome our customers to witness industrial-scale testing of their own material under realistic conditions. The flexible process sequence allows us to develop and optimize the right processing solution according to the customer's needs. For refining ZORBA from auto-shredder residues, we start with magnetic separators to recover ferrous and other magnetizable materials using either an overbelt suspension magnet type STEINERT UME or our double-stage magnetic separator STEINERT MRB. The remaining material is passed over an eddy current separator to remove non-metallic pieces such as plastic, wood or stones in order to create a cleaned concentrate of non-ferrous metals for further upgrading. The product of such a non-ferrous separation is a mixture which, depending on the input, consists of aluminium, copper, brass, zinc and other non-ferrous metals. Equipped with an X-ray scanner, our combined sorting system, STEINERT KSS, separates light and heavy metals due to their density differences in a dry process. In the first step, heavy metals like copper and zinc are removed from the aluminium mix by using precise compressed air blasts to move targeted pieces over a splitter plate at high speed. While coarse particles of a heavy non-ferrous concentrate can be processed with our STEINERT KSS XF, also fines can be treated using X-ray fluorescence technology with the STEINERT chute. XRF allows us to produce clean metal packages based on elemental composition like clean copper or zinc or brass concentrates.
That was our detailed look at ZORBA sorting and STEINERT solutions for this. If you have any questions in the meantime, please feel free to send an email to sales@steinert.de. And don't be afraid to miss something. We will show you this email address several times in this keynote. Stefan, now let's talk about aluminium recycling. STEINERT has been focusing on this topic for several years. And to get it started, why is aluminium so important?
Aluminium and the use of aluminium is increasing. Therefore, also the amounts of aluminium that can be recycled is also increasing. Aluminium as a light metal is used in many ways. So we can find it in cars or other vehicles for light construction to save energy costs during the use phase. But we also find it in buildings, for example, in frames, window frames or outside walls. But also as a packaging material, aluminium is very much used in form of beverage cans, for example, or aluminium foils.
And why does it make so much sense to recycle aluminium instead of producing new aluminium?
Compared to the production of new aluminium, it saves a lot of energy. So to make recycled aluminium, we just need 5 to 10% of the energy compared to making primary aluminium. And on the other hand, we also know that with most of the other metals, the properties of the metal aluminium can be kept the same without getting worse. So it can be recycled again and again.
It's still very present to me what Karl Hoffmann said in his opening regarding the global challenges, and that is that aluminium can be recycled an infinite number of times. What are the requirements for this?
The key to do so is definitely the scrap quality. So smelting plants need homogeneous composition of the material so that fluctuating qualities do not destroy the entire production batches, for example. To achieve this, we think aluminium scrap sorting today in 3 stages. And the first stage is to make a homogeneous quality and a more consistent quality, because that simply contributes to the subsequent treatment.
And this is a problem sometimes?
Yeah, smelting plants always struggle with inconsistent qualities. So let's talk about the process. As with ZORBA, we typically start with crushing and screening to prepare the material for the sorting process. However, after screening, the first stage of sorting is magnetic separation to extract the ferrous and ferromagnetic components out of the non-ferrous metal stream, which is very important because iron is, as an element, highly undesired in every aluminium smelting. And next, there's the eddy current separation to clean the non-ferrous concentrate from non-metals like plastics, rubber, wood, for example. And with these 2 sorting steps, we have already achieved a higher value because the material is also more consistent and having less impurities.
So you simply put mixed material in and get clean metal mix out. and sell your scrap at a higher price. That sounds great and simple to me, but how can we now get clean aluminium?
Yeah, you are right. So we still are talking about a non-ferrous metal mixture, which consists of light metal, aluminium, and also heavy metals. In stage 2 of this process, we need to remove the heavy metals. And this happens in modern processing plants using X-ray transmission technology. Here we can use the density as a stable characteristic to differentiate between the light metals and the heavy metals.
Can you explain this technology to us?
Basically, we come back to our system KSS. Here we use our STEINERT XSS, which consists of a conveyor belt and also an X-ray transmission scanner, where every single piece is detected and classified according to the density classes. And then again, we use the compressed air blast to eject precisely the single pieces. That means that our system can detect, classify, and eject the pieces in a blink of an eye.
I understand X-ray technology is the key to separating light and heavy metals to get clean aluminium. What else can be done with this technology?
First of all, we need to cover the free heavy metals out of the mixture. That can be a piece like copper, for example. That is a clear heavy metal piece. And we also have composite materials, consisting of more than one material, this piece, for example. Here we have a aluminium cast as a basis, but we also find an iron bolt inside. Or when we take an engine part like this, then we see it's mainly consisting of aluminium, and it's quite heavy, but it has a lot of pieces inside that are made of heavy metals. In this case, it would be magnetic because it's an iron inclusions. But this is something we need to take out of the aluminium batch because it's an impurity there. And this can happen with using X-ray transmission technology quite easy, because we don't need to have the pieces on the surface. We can look through the objects and also find intrusions and impurities like heavy metals in the inside of the piece as well.
Are heavy metals also present somehow else?
Yes, alloys are a challenge as well, because sometimes metals such as manganese, copper, zinc are added to an alloy, an aluminium alloy, to improve certain material properties like rollability for the smelting process. However, these conflicts with the smelter's demands to get the highest possible purity of such a scrap fraction. So to use aluminium as a secondary raw material in as many ways as possible, there's often the demand to minimize the amount of the alloying components as much as possible. And our solution to do so is X-ray transmission when it comes to the heavy metals.
And let's talk about magnesium. What about magnesium?
Well, magnesium is also, depending on the input material, it can be present as free magnesium alloys. And then it also can be detected and classified according to X-ray transmission, because it is light metal as aluminium, but it is slightly lighter than aluminium, so therefore it can be detected and separated into the desired fractions.
I understand, in summary, it can be concluded that without separation, the more valuable wrought aluminium will be downgraded. Is it therefore preferable to separate cast and wrought aluminium beforehand?
Yes, absolutely. And luckily, we have the right technology here with our STEINERT XSS. We can separate the cast from wrought aluminium according to the different amounts of alloying components inside the alloys. So there's a difference that is detectable. And talking about alloying elements, we come to now stage 3 in aluminium processing, which reflects the current state of the art of aluminium sorting, which is then alloy sorting. So to produce different alloy grades by using a LIBS technology with our STEINERT PLASMAX. So the STEINERT PLASMAX uses laser-induced breakdown spectroscopy, which basically works by using a high-energetic laser beam that evaporates matter on the surface of each piece. That again creates a plasma beam, which can be analyzed accordingly. And then we can conclude on the elemental composition of each piece. And after classification, we again use a compressed air blast to precisely eject the different pieces into different fractions. And by doing so, we can directly meet the desired qualities for meltable fractions according to the needs of the industry.
All right, so I see smiling faces at the customer's side. Stefan, after introducing us to alloy sorting, your dear colleague Simon Janßen will now demonstrate how this process works and what other features STEINERT PLASMAX has to offer.
Hi, I'm Simon Janßen and I'm a Solution Sales Manager in the Metal Recycling Division at STEINERT. Today we're in the test center in Pulheim, close to Cologne, and I'm going to present you 3 key features of our latest technology, the STEINERT PLASMAX LIBS. The first feature includes a unique feeding system, the second one is belt and multi-spot analysis, and the third one is the possibility to sort up to 3 products at a time. It all starts with a new developed 2-stage feeder system. It pre-accelerates the material, it distributes the material across the working width, it leads to a smooth transition onto the belt, and there we have a very even and singulated material layer in moving direction. The first detection step is a 3D laser triangulation. It includes a low energy linear laser across the working width, a 3D camera which is filming this laser, and with this technology we're able to measure geometrical properties of each individual object, such as length, height, width, volume, the shape, as well as the position of every piece on the belt. In the PLASMAX we have a special arrangement of the lasers and the spectrometers. We're scanning from underneath, so the distance between laser and material is very even and leads to a very stable recognition of the plasma. There is no need for a readjustment of the spectrometer and the laser. Each object is measured multiple times. We call that multi-spot analysis. With this technology, we receive more data and increase the stability of the detection. With the PLASMAX, we are able to sort 3 products in one sorting run. We have installed 2 valve bars. One valve bar sitting at the top, shooting down, the second valve bar shooting from below. These unique features enable us to sort into different material classes. We are able to sort into a 6000, a 5000 or a 3000 series, or any other aluminium alloy you want. Conclusion. With STEINERT PLASMAX LIBS, we detect chemical composition based on LIBS technology. Contactless, in-flight, real-time. And now back to you in the studio.
Very impressive what Simon has shown there. You really can't tell the parts apart visually. So I learned that we separated them from each other because of their composition. Is that also taken from communication and from listening? Is that what your customers are asking for?
Yeah, well, so I think In total, we have about more than 750 different aluminium alloys in place, and they all have their different chemical compositions. But typically, our customers are asking for separation of alloy groups or classes like 5000 and 6000 material, which is just a slightly different amount of silicon and magnesium, by the way. And some are also looking deeper and having higher requirements, and because they are looking for a specific alloy set or a specific alloy, for example a 6063, which is possible to reach with the PLASMAX. But actually every smelter has its own set of limits for the different elements. So this is something that we of course also can set up with our system according to the input composition. We can then adapt the program according to the requirements, and then to produce the aluminium concentrate according to this specification.
Okay, you can sort your favorite alloy with the touch of a button, so to speak. That's incredibly cool and an even deeper step into sorting. What else makes the STEINERT PLASMAX so special?
In Simon's short movie, we have already seen, or we talked about some unique selling points in terms of design, and I would like to emphasize on three points especially. So let's start at the beginning. Here we have a two-stage feeder that was specially designed for this unit, and here we achieve a high belt utilization in order to have a high capacity for the machine without any overlappings of the material in the detection area. And on the other hand, we have our multi-spot analysis, where we have and we can see it on the piece that the laser has drawn a line, which simply means that we have a lot of single measuring points for every single piece. That simply leads to a high accuracy of the detection.
And what happens after this classification?
Yeah, then we go along with the standard way to separate the materials using a compressed air blast. But in this case, we use 3 discharges. So we have 2 valve bars to eject 2 positive fractions and to drop 1. And this makes it possible to separate in total 3 products in just one batch. And the key point here is that a technology that was several years ago just something to find in the lab is now ready for industrial scale with high robustness, high capacities. And this is exactly what STEINERT PLASMAX makes so special.
That's a very strong closing statement for the aluminium recycling topic block. And at this point, we would like to call on you again. So if there appeared any questions, if you want to know more about sorting aluminium, please feel free to write an email to sales@steinert.de. Stefan and his team will immediately answer your questions. Let's take a look back at Karl Hoffmann's opening words. For him, in the future, it will be a lot about reducing carbon dioxide. Stefan, is aluminium recycling already making a noticeable contribution here?
Very clear, yes. So globally, the proportion of recycled material in production is increasing sharply. And on the other hand, the production of primary aluminium is declining. So that means that the share of secondary raw material, aluminium, is already increasing. And overall, that means that it leads to a lower CO2 emission, which is significantly reducing the amount of resources and energy to take. However, aluminium is by no means the largest metal stream that ends up in recycling. Sebastian, what do you think, from your perspective, what is the largest material stream that goes into recycling?
When I think about my daily consume, I start the day with my yogurt pots made of plastic, so my guess here is plastics.
Yeah, well, Almost. So at more than 700 million tons a year, steel scrap is the most recycled material stream globally. And that is because steel can be recycled an infinite number of times without losing qualities. However, the steel making industry is facing major changes and challenges right now.
Can you share some of those major changes?
We always have the keyword in mind, green steel, which comes along with a lot of regulatory measures that puts pressure on the steel making companies. Like stricter export controls and increasing CO2 pricing. That all, among other things, puts a lot of pressure.
But is there also a supportive approach?
Yes, there are a lot of funding programs that intend to create some incentives to invest a lot of money into low carbon production of steel. This also includes the shift from standard or conventional steel making routes to low carbon steel making. And that, for example, means that we come from a carbon-based furnace route where we use steel scrap at a maximum of 20 to 30% in terms of cooling scrap. In a new processing flow, we use more electric arc furnaces, so called EAFs, where it is possible to use up to 100% of steel scrap and melt it directly. So this simply means a much higher scrap content that can go directly into steel making processes.
So significantly more secondary material can be used here?
Exactly, and higher scrap utilization simply means higher recycling rates. And the key for direct utilization of larger quantities lies in the quality of the corresponding steel scrap grade. And in particular in the separation of or reduction of unwanted elements like copper and other substances. But depending on the composition and also the dimensions of the material, we classify these scrap qualities into different grades. Today I would like to have a closer look on the E40 quality.
And is this quality like a basic description of different trading categories?
Yes, exactly. So the mentioned type E40 includes, for example, end-of-life vehicles, so car bodies, but also white goods like washing machines and other mixed scraps that has been processed by a shredder.
And yeah, you mentioned this shredder. What happens after shredding?
After shredding, firstly, we take out the ferrous from this shredded material stream using our large drum magnets, which then accounts to up to 70% by mass of the material stream. But in this magnetic field also composite materials can end up in these magnetic fractions. And that is something that is also a keyword in industries, is the so-called meatball, which also ends up in that fraction.
Okay, meatballs sounds a bit strange if you haven't heard that before. What is it about these meatballs?
Meatball is a common term for these pieces here, which are copper armatures coming from electric motors. And these consist mainly of a iron core and a surrounding copper winding. So therefore, these pieces are responsible for a major part of the copper inside this magnetic fraction because it is magnetizable, as of the ferrous here. And nowadays, these pieces are separated from the other steel parts by manual sorting on a global perspective.
And that's what you just demonstrated, hand sorting here. And this doesn't sound particularly efficient and is certainly very limited when we think about processing and sorting. What's your solution at STEINERT for this?
Well, at STEINERT we have the concept to use our STEINERT SteelMaster to do so, to sort this magnetic fraction on this machine, which is a magnetic ballistic system, where we can separate very nicely the clear ferrous scrap pieces, which are much better magnetizable than compared to the meatball fraction. And this can be separated using the STEINERT SteelMaster quite efficiently. So a normal requirement or standard requirement with regards to the E40 grade is to have a copper percentage as a maximum percentage is 0.25%. Some customers even require 0.2%, which is also commonly used. And this is something we can achieve by just using the SteelMaster without any additional hand sorting to achieve the E40 quality standards here.
So the SteelMaster from STEINERT is therefore a robust technology for complying with today's limit values, as you mentioned. Can this technology also be used to detect other impurities?
The SteelMaster is a powerful piece of equipment to reduce free non-ferrous metals and free non-metal parts, which also can be part of this fraction. But when it comes to other specific elements inside of a ferrous scrap, for example, then we need to have a closer look on the material, and then we also need to detect the elements, so the elementary characteristics. Look at these two pieces to give you an example. The one has a much higher copper content than the other. Visibly, they look the same. And this is something where our X-ray fluorescence technology can find the difference, and therefore we can also sort it. And that also helps when we come to coatings like nickel or chrome platings, for example. This is also something that is quite easy to detect with XRF. And even when we have common elements in alloying systems like manganese, molybdenum or tin, then this is also something that we can detect using XRF. So therefore we see a high potential for this technology and also the increasing requirements in the production of green steel.
And how XRF actually works will your dear colleague Isabel demonstrate now.
Hello everyone. My name is Isabel Heinrichs and I'm working as an application engineer at the STEINERT Test Center here in Pulheim. Here at the test center we carry out customer trials on a daily basis using our STEINERT KSS XF L, featuring a working width of 1 meter and thus delivering results at a truly industrial scale. Once the material is fed onto the machine's conveyor belt, we first capture 3D data and determine the exact position of every object on the belt. The material then enters the heart of the system, the XRF detection zone housed within this scanner unit. Here's what happens. The material is excited by X-ray radiation, causing it to emit fluorescent radiation. This is detected and analyzed using a spectrometer, allowing us to sort it with extremely high precision based on the elemental composition. Detection with our machines is completely safe. The X-ray radiation is generated electrically and is only active during operation. Even when the radiation is on, I can stand safely near the machine because of its highly secure shielding, compliant with all technical safety regulations. Now let's take a look at the sorted material. From the original material stream composed of steel scrap, meatballs and copper, we've now enriched pure steel scrap. The separation of unwanted and foreign elements using X-ray fluorescence is both straightforward and highly precise. The STEINERT KSS XF L achieves a throughput of 35 to 70 tons per hour at 1 meter working width, depending, for example, on the material's density. Conclusion. Designed with extra rugged components tailored for steel scrap processing, the STEINERT KSS XF L is built to endure tough sorting environments, reliably and efficiently. Thank you very much, and now back to the studio.
Stefan, that was a really exciting insight into the most important technologies in metal recycling. Before we close this STEINERT keynote, let's talk about where the journey is going. What can we expect in the future?
Yeah, so we see a clear trend, and that is always towards a increasing sorting depth. So what was not thinkable just years ago is now reality, such as LIBS technology in an industrial scale process line. In addition, we also find increasing demands from the market towards recycling, but we also always see new and changing legal framework conditions and of course new and changing materials that we need to adapt on.
And what about artificial intelligence in metal recycling?
That is also increasingly playing a role here, and we use it, but not just to label it machine like it's smart, but wherever it gains some precision and efficiency. But our goal remains the same. We are looking for high quality secondary raw materials. We are looking for a maximum circular economy. And this all has to happen on an industrial feasibility. So, and to achieve this, we are constantly developing our product portfolio further, and that happens together with our customers.
Thank you very much, Stefan, for letting us participate from your expertise.
Yeah, thank you for hosting.
We hope you are able to take away some new impressions from today's keynote. If you are planning your specific project, please feel free to contact our STEINERT experts. Our experts around the globe will be happy to give advice and support you with your project from the very start. And also to mention, our test center is always available for real-scale trials with your sorting material. I underline this, with your sorting material. Thank you very, very much for joining the very first metal recycling keynote by STEINERT.
Thank you and goodbye.
See you soon. Goodbye.